All right, so hi, I'm Josh Lee. I'm developer advocate at Altinity, and I'm joined today by Justin Mason, who will be starting at Mongo next week. Justin, would you like to introduce yourself?
I'm Justin Mason. Been in the software industry a long time, worked a lot around metrics, large data pipelines, and telemetry. Um, Starting actually very soon as a senior staff engineer at MongoDB, and we'll be helping work within that telemetry space there too as well.
And today we're going to talk a little bit about a PR that you made for the OpenTelemetry collector contrib library for the ClickHouse exporter specifically.
Yeah, I can
Cool.
kind of jump in, um, kind of talk through some of the things that ClickHouse can do and where this whole ClickHouse piece fits in OpenTelemetry. Seeing my browser, I assume.
Yep.
So I guess I'll start off with the OpenTelemetry project. One of the big things with the OpenTelemetry project is this thing called the collector. There's a base core OpenTelemetry collector, and then there's the community contributions. So the OpenTelemetry collector contrib library contains a bunch of contributions. And I'm not going to talk a ton about OpenTelemetry today, but keep in mind that there's receivers that can get data, there's exporters that can send data, and there's these processors in the middle. So this whole collector is around that type of model. And if you just to kind of see the adoption of OpenTelemetry, you can see within exporters, which are sending data downstream, there's a ton of, large industry leaders contributing to that. And the same thing with receivers. If you look at the receivers, you'll recognize a bunch of very large technical companies and leaders in the industry. But we're focused really on the ClickHouse. So ClickHouse provided an implementation of an exporter, and this is just a community contribution to this. And this exporter is designed to send data to ClickHouse, and it actually will generate schemas and those type of things. So if I look at kind of the database, so as soon as you run the ClickHouse exporter, it's going to generate your database schemas. Depending on what you're using, if you're using metrics or using logs or traces, it'll actually create the corresponding schemas in your database if they don't exist. And there's some kind of advanced ClickHouse stuff you could do around that. But as a default, it's just going to generate these schemas. And what we're going to look at is the metric schema today. And these are all the fields that are really standard to OpenTelemetry. Whether you use them or not, it's kind of in your own purview. A previous company I worked at, what we ended up doing is leverage this whole pipeline to take metrics from our global distribution of clusters and funnel them through an OpenTelemetry pipeline and get them into ClickHouse. So part of this is just kind of talking about that overall high-level architecture and some of the things to consider in that.
So that allowed you to take all that list of receivers and just funnel it all into a unified format.
Yeah, so the whole OpenTelemetry pipeline, and I can kind of show you what that looks like. Maybe that's an easier way to do it. So what I ended up creating with my own collector, without going into detail, there's a builder that you can use to create your own collector. And in this collector, I've got a receiver, which is a Prometheus write receiver. And I created a Prometheus write receiver so I could take Prometheus data and send it to this guy. And what you see down here is the output of this guy running. Right now he's running and he's getting the metric data from Prometheus. He's converting it into OpenTelemetry, and then it's pushing it to ClickHouse. So this pipeline, and if you look at this configuration, this is this is the OpenTelemetry spec for the configurations for the collectors. And here I'm defining my receivers, and there's my Prometheus remote write receiver. I'm defining my exporters, and there's my ClickHouse exporter. And then I'm specifying some configuration values around. So each receiver implementation and exporter implementation and all the stuff within there has their own configuration that you can provide.
Cool.
That makes sense.
Yeah, that's awesome. Okay, so we can take all these things and put them all in ClickHouse.
Yeah, so this is really showing the pipeline and the pipeline of getting data from Prometheus and sending it to ClickHouse. And then the pipeline also has some batch things that are optimized. As a side note for ClickHouse, you don't want to do a lot of granular inserts into ClickHouse.
Yeah,
So you
definitely.
want to batch it. So the cool thing about this It's already kind of built with a lot of that stuff in mind. So there's really low level of effort to put out a pipeline that can take data from various receivers, and you saw the list of them, and then export it to various exporters. And this one just happens to be ClickHouse. One of the cool things about ClickHouse and using this exporter is the amount of compression rate you get on the data. So at my previous company, we had a large number of metrics across the globe that we were funneling through, generating, petabytes of data to store all these metrics. And what I wanted to show you where ClickHouse has really shined in that solution is the compression rate you get. And this has just been running for not even a day. So you only see a 156% compression, but that's still pretty amazing that you're getting that much compression off this metric data. I've seen this data size as it grows up to really large, you get better compression the more data, I guess, you get in there. And I've seen over 350% compression.
Oh, that's awesome. So I was
once
going to ask, why use ClickHouse for Prometheus data instead of Prometheus? This is obviously one of the reasons. Are there others?
I think the big reason is the performance you get on the queries response time and the amount of data that you can store, and the fact that you can store it a large amount of data over time. I mean, Prometheus isn't really as ideal for long-term storage of metric data. I know companies I've worked at, 30 days or 90 days is about the threshold, and then it just
Yeah, that's not very useful if you have a 7-year audit requirement.
Right, exactly.
Yeah.
Yeah. And with that compression rate you're getting, and we're not even talking about getting into sharding and some of the other things you could do to help that compression rate is pretty amazing. You're compressing data down over 150% for just a small data set. I've seen it much greater. So you can store years worth of data for a very small amount of disk cost. So this kind of just shows you that compression, and I wanted to show you the schemas that get created and the fact that there's just a bunch of schemas here that are getting created. So the next thing to really look at is the queries. Now that you've got this data and it's being stored, and maybe it's worth showing you what it looks like in raw, like if I just do star metric sum, just limit this to records.
And it looks like we're getting a table for each different metric instrument type.
Yeah, exactly.
Yeah.
So that, the builders of that exporter, there are other people that have built around. Signals is another company that's built a OpenTelemetry collector pipeline against ClickHouse, and they have a different schema that they decided upon. So whoever implements the exporter can decide on some of those factors. But yeah, at the end of the day, this ClickHouse exporter will create these schemas as soon as you start pumping metrics through that collector. What it's storing in this collector is the raw data from Prometheus. So Prometheus right now is just doing a remote write to my collector. My collector is converting that into OpenTelemetry and then sending that data in. And if I'm kind of just scrolling through so you can see what that looks like. It's taking all the Prometheus attributes that were part of the PromQL response, and it's sticking them in a map within ClickHouse. So the beauty of the solution too is now you can keep all your metrics very generic. I don't have to create new schemas for new metric types that have different attribute sets. I can just store them all in here, and then that map type will store all the different types of attributes that each individual metric could have. And then you can see it's storing the value, but the point of this is we're storing the data almost like Prometheus is. We're storing it as we get it through our batched pipeline, and we're storing the raw data. So that means if we want to actually calculate time ranges for usage, we can use ClickHouse's windowing function, and on huge volumes of data, we're still getting sub-second query of real-time aggregation of these time intervals. So at previous companies, we wanted to be able to calculate 1-minute intervals, 5-minute intervals, hourly, daily, monthly. And storing the data in its raw format is kind of powerful because now I can just do that on the fly. So that's kind of what I was going to talk about next. So I put on my GitHub account, I've got this thing called the exporter client. It's a work in process, but in here we can kind of see how we can take that generic schema and we can query it. And it might make more sense to scroll down to kind of like how we can see it in Grafana. And I'll show you in a second the Grafana dashboard. But in PromQL, I can have a query like this that says, hey, I want to sum the increase over 5-minute intervals. And I want to group that by handler. While ClickHouse doesn't support PromQL currently, you can achieve the same type of thing calculating on the fly using a query like this. And this query is based upon what Altinity and the ClickHouse community has already provided within their Altinity plugin for Grafana ClickHouse. It's probably worth looking at that. So if you're using that ClickHouse exporter, there's already an Altinity plugin. There's a ClickHouse plugin too by the ClickHouse community that works against that database schema that I just showed you. And it's got basically a bunch of macros that are designed to help you plot data out onto Grafana charts. I'm just scrolling through here. So here's a bunch of the types of macros that are already built in. And then it shows you like how to do calculations. So it gives you the example of how that looks when you're querying it. So the query that I'm showing you here is based upon optimizing that for sub-second query over large data sets. I originally tried to use some of the Altinity queries that were in Grafana, and while they rendered nicely in Grafana, they weren't fast enough for real use cases. So this is that query, and then I've got some code that does some query building around it. So looking at the equivalent, this query here is grouping by handler and code for this metric over 5-minute intervals. And then down here, the only thing that we're providing for the intervals is the number of seconds. So this, if you want a different interval, like an hourly would be 3,600 seconds, a minute would be 60 seconds. So by just changing the interval that you're using to group your data on, you can take that raw metric data in ClickHouse and aggregate it across those data points. So in this example, using those generic attributes too, you're just attributing and concatenating these attributes together to create groupings so that you can group the metrics the way you want, so that if you've got a metric and you've got some identifier for a customer, you want to make sure you group those customer metrics differently. So that's kind of the idea behind grouping by attributes, which is really a common use case when you're looking at these metrics.
Yeah, I think Grafana sort of wants your time series to be like each interval and each group sort of in order.
Yeah, and that's the thing. And I jump over to Grafana, and that document, I've got that readme up on my GitHub, but over here you can see it kind of in action. So up here on top is a Prometheus PromQL query, and down here is the ClickHouse, the exact equivalent of that ClickHouse query. And since we're grouping by code and handler, you can see what really happens. And when I'm looking at data, is you're able to kind of group across those metrics. So there's the good one that I had, query range. The query range had, and this was just some sample data I was running. So if you look at the values that are getting plotted, they're going to be slightly different, but they're going to calculate to the same value, because Prometheus is storing this data in its own format, and it's doing the calculations on the fly to create that increase, which is a typical counter metric. It's always increasing. If it goes back, it's considered a reset. So PromQL does all that, stores its data in its own way. We're doing it over here. And if you look at the values, they're incredibly similar. If I scroll out to like the last 3 hours, you can see kind of just at a glance that this data is calculating out to be equivalent, is probably the best way to put it, the way increased metrics work.
That's amazing. So when we were talking before, you mentioned you tried to use materialized views to solve this performance issue, but I think that's not how you ended up solving it. You used window functions.
Yeah, I think one of the things I originally thought is I wouldn't get good enough performance off of the storing the attributes generically in a map. And one of the things, ClickHouse and materialized views, you could pull out. So like in my example that I was showing you over here, I'm referring to two columns, a handler and code. And that handler and code may be important. At a previous company, we had like customer identified, information in there that we wanted to pull out and filter on with an aware clause. So I had originally thought that the attributes wouldn't be performant. So a materialized view, I could have pulled out handler and code into their own columns and a different materialized view. And that way, maybe it would be more optimally performant. But what I actually found is that this query, after kind of refactoring it from what the Grafana Altinity templates were into using windowing functions, this was giving me sub-second response time on huge sets of data. So because of that, I could keep the attributes in the generic map. And now all new metrics that wanted to get into this pipeline didn't have to do anything. I didn't have to create a new materialized view for each metric type to call out the right columns or attributes that needed to be filtered. One of the things that I wanted to touch on that you mentioned was that pull request. And I think this is kind of a cool thing in general from a ClickHouse knowledge point of view, working with Go. So that currently the ClickHouse exporter doesn't explicitly sort the map that it's sticking into ClickHouse. And what that causes, and this pull request is going to be addressing it. It's getting close to being approved, so hopefully it'll be merged before too long. But what I found is in ClickHouse, if you're storing a bunch of map records and you're not explicitly sorting the keys, each unique sort order is actually a unique record, and you're not going to get what you really want out of both the compression of the data and also even the validity of the data, because you could see duplicate records because the attributes in Go didn't maintain the order when it got passed on to ClickHouse. So they're all getting, different ordering, which is never good. Mm-hmm. So this pull request does something that's kind of cool from a ClickHouse point of view. ClickHouse, using their API, has this idea of an ordered map. So you can create an ordered map data type, and when you create the ordered map data type and use that as the column value when you're updating ClickHouse or inserting into ClickHouse, it'll maintain order. And it does that by, you create your own type that maintains the keys and values, and then you just implement this column map iterator. And ClickHouse is smart enough to see if there's a column map iterator for this column, use it to populate the map when it's inserting it. And then now all of your order is maintained, which is good. Yeah, prior to this, we had a materialized view mainly to get all the records and then do an explicit ClickHouse map sort so that we could do the same thing. But I think it's worth noting that compression and duplicate records sometimes were seen, and that caused a lot of concern until we realized it was just a map ordering issue within the database.
Yeah. And that's one of the things with the, these OpenTelemetry libraries. They're awesome, but they can be unbattle tested and have things like this that come up.
Yeah, and if you look, I was pulling this guy back. So the ClickHouse exporter today, the community and the OpenTelemetry community in general is getting very mature. You can see the amount of there's AWS, Azure, Google, all the big players are really starting to get involved. And when you look at these, you can always see what status this is. So currently the ClickHouse exporter is beta right now for logs, and it's an alpha for tracing metrics. So it's definitely still a work in progress, but for the needs that we had for the metrics and for some of the customization that you can do on top of it, it worked very well, ran very stably for a long period of time.
And it's open source, so when it doesn't do what you need it to do, you can make a PR.
Yeah, and that's kind of what I was alluding to. I've got my collector, and this is my own collector here. So if you really wanted to fork one of the receivers that are out there and not wait for the community to contribute, it's pretty trivial to build your own collector. They've got a builder framework, and you can go in and basically, and that's this framework, you go in and basically specify, I want to create a builder that has these exporters and these processors, and you can tell it to build it, and it'll basically build the stenciling around this Go project. And then you just go and implement your own receivers yourself. So that's the solution that we ended up coming with. Is we needed some stuff that wasn't part of the community yet. The goal was to contribute back to the community, and that's part of what I'm trying to do through some of these pull requests.
That's awesome. Thank you. Thank you for that. I feel like we have to show this window function query, right? We've been talking about it. I'd love to see sort of how that works.
So this is the function broken down, I guess.
Okay.
It might not be formatted as prettily as we would want. But the key with calculating increase is that you need to know the previous value in order to take the current value and subtract from it so that you get the difference. Because some metrics, increase metrics, both in Prometheus and in OpenTelemetry, basically always increase. And if you see them ever come down, that's considered a counter reset, and then you recount from that new count permission. So the windowing function up here, and that's kind of what it's doing. It's using the lag and frame to get the previous value. So this function is saying, what I care about is grouping by handler and code. And, in my previous company, we might group by different types of IDs that represented the companies that we wanted to group by. What I'm creating is like a key that this function will use to group the data so that when it's calculating the increase from one metric entry to the next, it's only doing it for that group.
It creates a unique time series based on that combination.
Yeah, exactly.
Yeah,
exactly.
Okay.
And then you get a count to figure out what the actual, is there a pre-existing, and that's what this is doing. If there is a pre-existing record, then you want to use that pre-existing record in order to calculate the difference. If there's not a pre-existing record, then you're considering that as 0. And then ultimately, this is kind of the little if condition that's comparing the previous value with the pre-existing keys to say if it's already existing and the value is greater than the current value, which means we're increasing, which is what we want to do, then ultimately we're going to make the value equal the value subtracting the previous value. So we're getting the difference between the two. And that's where kind of this was a little bit hard.
That way you handle monotonicity breaks.
Yeah, because what you're saying is as long as my current value is greater than my previous value, I know I'm in an increase and I just need to subtract the two to get the difference. If not, I'm going to say that's a counter reset and I'm going to go to 0. Yeah. So the 0 basically says now when I'm calculating it, the next value will be the difference of 0 and the next value, which will now give me the correct increase. And that's more like how increased metrics are calculated. It's probably a longer talk than this, but that's kind of all this is doing. That's the cool thing about this lag and frame function is that you can look back and compare different values. And there's a lot you can do with these windowing functions within ClickHouse. And like I said, this is really performant too, especially when you're got your data and you're targeting the exact data that you want. It looks very fast. And then on the outside, we're basically taking it. And since I created this key, that's really a combination of concatenating the things that I cared about for grouping, I re-extract it out here so that I can get the specific fields so I can handle them. So let's say you wanted to actually provide this back to an end user in a more of a clean way. Once you've grouped the data, this internal subquery is actually doing the main calculation of increase over time. And then this out query is basically re-breaking it out so it looks more like a flat table. That's where you're seeing like handler here and code here, which were just extracted from this compound key that was used to group it.
Very slick. Very, very slick. I mean, it's a gnarly query to look at, but it's very cool how much it's handling and what it's doing and how fast it is.
It's less gnarly than the original one.
That's true too.
It's using windowing, which the other one was using some deprecated functions to do some other things. So the windowing is actually, and the shining is like the performance that you're getting on these queries. Like I said, I was very impressed that we didn't have to break out the materialized view in order to treat these attributes as first-class columns. We could just keep them in this generic map and still get great response off the queries.
That's one of the things I love about combining ClickHouse with OpenTelemetry is just you can shove cardinality anywhere you want, and you really don't have to think about it or care about it.
And one of the things, and this is kind of is just a note, is we did ended up looking at reducing the amount of data for long history. So for TTL, let's say, for the last 45 days, you want to keep data at, 30-second increments. But then after, that for the last year, you want to keep it maybe at 5 minute. And for the last 5 years, you want to create, monthly. Using materialized views is a great way in ClickHouse to do that because you can just cascade. What I ended up doing is the original table. And if you look at this table definition, what's the actual explain plan? It's let's show table create. There you go. It's always nice. So what you'll see in the default table that's created, and you can look at the code within and how they create tables, and you can actually, they now support creating distributed tables and creating tables across a cluster and some of that stuff which is what the replicated merge tree and stuff. So by default, this just uses the regular merge tree. But going back to what I was talking about, the different TTLs over different time intervals, and this actually, Altinity helped recommend this to me, is to make this table a null table. So a null table in ClickHouse means the exporter is going to write to this table. And my summary of what a null table is, it's just kind of like a procedure that will intercept the inserts and allow other materialized views to intercept those inserts so that they can persist them in a different schema. This way to put it. So by using a null table, the ClickHouse exporter could just write to this table schema, and then you can hang materialized views off that null table to intercept that and then aggregate that data down. So you can use that aggregated merge tree and then pre-aggregate your data into different time intervals. So if you wanted to, get rid of the fidelity and get it down to 5-minute intervals, you could do that through a materialized view, aggregate that data down to a 5-minute interval. And I think that's a pretty beneficial thing that ClickHouse does too. It's like allows you to chain those aggregations across data coming in. And that way the export doesn't need to know anything more than I'm writing to this table schema. And then you've got a lot of ways to slice and dice that data downstream in ClickHouse.
Yeah. I want to know my P99 at 5-minute intervals, or that's okay. That's really cool. And then we're talking about metrics, but I imagine you could do something like if you're doing something with tracing, this is almost like the ultimate tail sampling because you have all of the data to make the decision about the trace.
Yeah, exactly.
That's a tangent, probably a topic for another call, but just something cool.
You speak to kind of like what this ClickHouse export is trying to do is provide a way, and those are the three core pieces of OpenTelemetry. So if you've got an OpenTelemetry collector and you decide you want to deal with metrics, now you could source that or get that data into any kind of database storage that you want. And you can see there's a huge list of them, Datadog, all sorts of different ones that you can see on this list. But now with this ClickHouse exporter, you can also push that data into ClickHouse, both the traces, the metrics, and the logs. And then, I think over time, the tooling is kind of where the industry is going to start putting more ways of making that consumable, a lot easier than some of the stuff that I've shown you, where you're kind of going in and having to build more complicated queries to extract that data and calculate increase. But it's all in there and it's very raw format. So there's nothing really preventing you from, building some cool connections on top of that data. You've got all three data sources now, or all three telemetries. Kind of the goal.
And they're structured. It's not like a data lake. It's all very structured, and you can query it with SQL and dig into those JSON maps. Yeah, cool.
And I think that's one of the cool things about ClickHouse is that it's columnar, and I think that's why you get such good compression. When I was showing you, the raw data as it comes out, there's a lot of empty fields in this record, but that's great. You're in a columnar store. None of that's really going to affect your data size. It's just going to not be considered. Cool.
Let the computers do what the computers are good at. Let the humans do what the humans are good at.
Right. And that's kind of it, just to show you that you can actually take that data pipeline today and get it moving and actually report on metrics in the same type of way you would want to do through like Prometheus or Victoria Metrics or another one of those platforms.
Well, this is awesome. Thank you, Justin. Thanks so much for sharing this, and thanks for that PR. And we're definitely going to take a look at that query and maybe incorporate some of those lessons into the Altinity plugin, so that everybody can use them without having to understand SQL and ClickHouse intricacies as deeply as you have learned them.
And that's one of the things I tried to do with this project. Yeah, I guess this project is I did build a little, and this is kind of a work in progress, but it's a builder so that you can use Go to provide the parameters in a much more easier programmatic way, and then ultimately generate this query. So if you look at this project,
Mhm.
that's kind of the goal behind this project, was trying to make a start on something to simplify the building of that query. And that's what this guy's doing here. And it allows you to set where clauses and those type of things, but ultimately it's taking this template and merging all the properties that you're providing and generating that complicated SQL.
Oh,
It's
that's
something
awesome. I'm gonna have to try that out.
Yeah, and there's unit tests over here where you can see the usages. So how you would actually use it, tell it what table you're. In this example, it's actually looking for this 5-minute aggregate table. Set your where clauses and then call build. And until you understand how to maybe manage the query on your own, this might be a good starting place for someone.
Great. Well, is there anything else? Is there anything you want to plug, or like channels people can follow you on?
No, I mean, at this point, I'm just excited about what OpenTelemetry is doing. I'm trying to get more involved in the community. And I am putting some stuff on my GitHub page to kind of show off some of the things you can do. But yeah, that's it. It's more just trying to share some knowledge.
Thank you. This is awesome.